using Bayes' theorem, the observation n equals 2, write down the posterior, which is this. So it was proportional to, oh, I'll write it in Word. What did I say? It's proportional posterior lambda to the power, what is k plus 2 minus 1 times x of minus lambda over theta. Oops. Okay. 1, 2, 3, 4. So that was the first A, B, C, D were 40 marks, and that was 25. So this is a substantial amount. I gave very generous partial credit. Anyone who realised you could apply Bayes' theorem to that problem there got a whole bunch of nearly half marks for just saying Bayes' theorem is applicable here, and we calculate the posterior by multiplying the prior by the likelihood. Even though most or nearly everyone was incapable of doing the algebra, people who recognised the concept got very high partial credit. Question 4. What time is it? past. Consider a class of 20 students who act independently of one another. We are interested in P, the probability of attending a lecture. One day a total of 16 students. They've got to act independently because you might talk to one another and say, right, we'll all come today or we'll all not go one day. So you've got to be independent of each other. So it's like tossing the coin. The prior PDF is a beta distribution. Let's just remind ourselves what the beta is. Beta distribution is P to the alpha minus 1, 1 minus P to the beta minus 1. P equals probability. Alpha and beta are parameters. Okay, and it looks like this. The prior PDF for P is a beta distribution with 13.2 and 1.4. Plot the PDF. Hint, use our idiom like this. Well, let's try that then. Actually, let's put that in the question, in the Word first. Right click, copy. Go to Word, right click, paste. Plot the prior PDF using idiom like this. No. Copy, go to R, right click, paste. A lot of people did that and just put that in, which is bad for two reasons. Let me go back to the question. It's bad for two reasons. Firstly, you don't get a pic because it's got such a short length. You don't get any picture of it's not. You don't get that nice smooth curve. But the real problem is this: people just plugged and chugged. I mean, come on! It says here distribution 13.2 and 1.4, and it says 6.6, 6.8. I can't understand why anyone would think at level 6 that cutting and pasting into R is worth 5. Anyway. So we need to modify the first bit and the second bit. So let's just do that. This is just to remind you what the commands look like, not to give you a cut and paste hint. So let's do that. Right click, paste. Let's give it a few more. Plot P, density of the beta distribution, P, and I've forgotten the numbers already.
13.2 and 1.4.
13.2, 1.4. There you go. Nice, isn't it? Could do even better than that. Comma type equals L. Right click, copy as bitmap, I think works. Plot the prior PDF. Right click, paste. And that's a bit big, so we'll make it a bit smaller. Done, 5 marks. State and plot the posterior PDF. One day a total of 16 students out of the 20 attend. You'll remember, again it's the same line of logic, that the posterior is proportional to the prior times the likelihood. This one here is p to the alpha minus 1, 1 minus p to the beta minus 1. The likelihood is binomial, of course, which is 20. How many came out of 20? 16. So because I'm interested in a function of p, I can just get rid of that because I'm only interested in proportionality. And it's now proportional to p to the alpha plus 16 minus 1 times 1 minus p to the beta plus 4 minus 1. Determine the prior state and plot the posterior PDF. So it's that 13.4 plus the 16 and 1.4 plus 4. Posterior is a beta with parameters 13.2 plus 16 and 1.4 plus 4. Yeah, because this is the number of successors who came and this is the number of failures who didn't, because there was 20 in the class, 16 came and 4 didn't. So we better plot that. Yeah, just add it. And what's it done? It's brought it back here. So we'll copy it again, copy as bitmap. Actually, I'll just grab that as well. Right click, copy. Paste. Courier new. Paste and make it a bit smaller so it's possible. So it's visible, sorry. Okay. What are the mean values of the prior and posterior? Well, the mean values was 13.2 over 13.2 plus 1.4. Yes? And now we've got that plus 16. So it's 29, isn't it, there? And that's 5.4, just adding 4. So my prior probability was 90% attendance, or that was my mean, according to my prior. And now that I'm in the cold, hard world of disillusioned real data, it's gone down.
It's 5.
Oh, a little bit. A little bit.
5.4 instead of 4.4 in the brackets is supposed to be.
Oh, good point. Because of course it's 1.4 plus the 4. Yeah, it's still gone down. That's a good example of an error which I wouldn't have caught because it looks sensible. And so when I've got this thing about, oh, can you catch your errors? Well, yes. It's great if you can catch them, but there are errors that still slip through. So this kind of numerical checking doesn't catch everything. So as well to be aware of that. Make it red, make it courier new, and we're done. You'll notice I don't need to say the mean of the prior distribution is alpha over blah blah. Look, if you do this, you've got the answer right. Don't waste time. It's not a primary school English exam. Next question. Using p beta or otherwise, determine the prior and posterior probabilities that p is less than 0.8. P beta gives me this. Here's my beta distribution. P beta so what I'm trying to work out is, according to my prior and posterior, what's the probability that attendance will be less than 80%? P is less than 0.8. This is the prior first, and the posterior. $29, wasn't it? There you go. So there's my answers. Red, courier, done. How can I check that? Direct numerical sampling. That's not very good, is it? Oh yes it is, look, that number there is the exact answer and there's my estimate. Yeah? I think.
I thought it's we've got P beta 08 13.21 before you got 0.098 07 and then you've got 0.09792.
Yeah, that's it. Is that right now? That's right, isn't it? 13.2 and 1.4. 13.2 and 1.4, yeah, so that should equal that, and it does almost exactly. Yeah? Right click copy, that's the prior, isn't it? Go to Word, right click, paste. What colour? What colour should this be? The question doesn't ask for it, so there's no point making it red because it asks for the theoretical probabilities. That's just a check. And if that number there was very different from this,
It's the trues, isn't it? You want the
it is the trues, isn't it?
Yeah.
Have I got these two numbers here the wrong way around, perhaps? Ah, that's what I've done. I've got those two numbers there the wrong way around, haven't I? So that number there should be that one, yeah. It's easy to do. Shape 1 and shape 2. You see, the probability is definitely less than a half, isn't it? It looks to be about 10% that it's less. So what am I doing wrong here?
You're asking it if it's less, and it's saying it's true.
Oh yeah, of course. It's true that percent of the time. Yeah, all right. Yeah, that's right. Yeah, I'm just getting myself tangled up. Explain, let's go back here. Explain in terms a non-statistician could understand why the mean value for the posterior is less than the mean value for the prior. Okay, well the observations has fewer attendees than expected by the prior. Has a lower mean. That's it. I'm not sure what happened there. Did I? That's it. See if I can highlight it without deleting it this time. Red, done. I've spent about an hour and a half doing this, but I've been explaining it too. I don't want the exam to be time limited. So the exam will be about that long with questions about that difficult. You will have the same environment that I've had. You'll have R, you'll have the page, you'll have the help pages from R, you'll have R to help you with your ideas. I might ask questions about what you're going to do in your portfolio as well. I'm quite keen that you take your portfolio around with you and think about it. But that's basically the form for the exam. And I'm going to stop there. Right. Thank you for your attention.